problem sticking your hand into a panel. If you have good gloves on, if you can see this meter.
Hi, welcome to NACHI TV. I'm Kenton Shepard, and I'm here today with David Rusgay from Positive Energy Electricians. David, thanks for being here.
Thanks. Glad to be here.
This is the wall of shame. It's a wall that's been intentionally miswired, and David is going to walk us through it. David?
This should demonstrate many of the things you'll be looking for when you're doing an electrical inspection. Problems that you may encounter, this should demonstrate all those aspects. I'm going to take these. You should always wear safety glasses when you're going into a circuit panel, messing with electricity of any kind. However, just for the fact that I see much better without them, and we're in the studio, I'm going to take these off and set them here. But we should always wear safety glasses when doing electrical inspection.
We'll be leaving our gloves on, though.
I will be leaving our gloves on. These wires are hot, and you do not want to get shocked. So these gloves will protect your hands at all times. Let's start with the service entrance conductors. The service entrance conductors are the large wires that you'll see coming into the panel that feed the main breaker and when the breaker is on, feed the main bus bar. These wires should come through either a conduit or some kind of nipple, and that nipple should have a bushing, plastic or metal bushing, on that nipple. This one, of course, has none, and that leaves you with a lot of sharp edges, and that can, over time, nick these wires and cause a very serious short.
So the first defect that an inspector would write up is the lack of a bushing.
Lack of a bushing. Lack, in this case, of not only a bushing, but a grounding bushing. Why do we need a grounding bushing? One, this is a metal piece of electrical entry conduit. And the fact that there are still concentrics, let me explain what that means. There's additional layers of knockouts still available so that you could actually go with a bigger entrance conduit. If they're not all taken out, you must use a grounding bushing.
Okay.
So right here we have two problems. One, there's no bushing of any kind, no grounding bushing, and that would have to be grounded to the grounding bus bar.
So that's grounding the tubing coming in. That's not grounding
correct.
The panel itself. That's just grounding the
just grounds
the conduit.
this piece of conduit to the panel, which is grounded to the ground. This is all a matter of constant flow to ground.
So anywhere we see that condition, like down here also, we should also see a grounding bushing there also.
Not true.
No?
Under 3/4 of an inch, from 1 inch and lower, you do not need a grounding bushing.
Okay.
I don't know why, but that's the code.
Okay.
But anything larger than 1 inch, you must have a grounding bushing. A very important aspect to look at first is the entrance conductors and the size of the entrance conductors coming into the main breaker. They must be sized adequately to supply this main breaker, or they won't be able to carry enough current.
Adequately meaning since this main breaker is 200 amps, they need to be 200 amps or less?
That's correct. 200 amps or more.
Okay, there we go.
Right. So they have to be able to handle 200 amps. And that size, I happen to know from experience, is a piece of 4/0 aluminum or 2/0 copper. Now, these wires do not say anything on them. I can't read where they say 4/0 or 2/0 or anything. And it is code that they must say on them what size they are. And actually, I'm wrong.
There's some markings on
there is
there.
some
They're hard to
markings,
see,
and you
though.
have to look closely. But this will tell you the size of the wire. There's some little writing here. This neutral is not 4/0. Now, how do I know it's 4/0? Well, I know from experience what a piece of 4/0 looks like, but if you don't, you need to be able to read the wire. If you can't read it, then you should call that out in your inspection.
So I've seen conductors, service entrance conductors, that were much longer than this and had writing on them, but none of that writing described the size of the conductor.
Well, it's supposed to.
So
and
maybe
that's what a factory installed, a factory created piece of wire does. It states the size of the wire on it. It's one of the most important things, the type of wire and the size.
So that just meant that it was further up inside the conduit and wasn't visible. So you just write it up as that it looks like the correct size if it does, but you can't confirm it, then it would have to be confirmed by
That's
electrician.
correct.
Okay.
Also, it's very hard to know the size unless you are familiar. I mean, I can just look at this and know. I can hold a piece of 10 wire in my hand and I can know what the size of this wire is. But if you're new at this, you're not going to know that.
Right.
There are a number of ways to tell, but you need to familiarize yourself with wire sizes.
What about using gauges? I understand that conductors have changed sizes over the years. Is it, what about using a gauge that you can hold up and use it to gauge the size of the conductor?
Well, the problem with that is the gauge has to go around the wire. For example, if I use this pair of strippers as a gauge, it has to go around the wire. You wouldn't want to do this to a piece of wire in a panel. If you turn the breaker off and take the wire out and put this strip, then you can know what size it is.
The ones I've seen have been gauges that had tips of different widths, so you'd hold the tip up to there and compare it to the width of the wire rather than the circumference.
Yeah, sort of like a micrometer of some kind.
Sort of like, yeah, you'd be measuring the width of the wire, the diameter rather than the circumference.
Well, that would be very adequate. And in the code book, those wires are described by diameter.
Someone told me that that wires have changed diameter. That conductors have changed diameter over time, just because they've begun to fit them together more tightly as they manufacture them.
Well, that's not quite true. The fact is, what they've done is they've improved the quality of the insulation around the wires. So the insulation has shrunk. A 4/0 wire is still a 4/0 wire. And
Gotcha.
Since you mentioned it, if you measure this outside diameter right here, you're really not going to get the gauge of the wire. The gauge of the wire is the actual stripped part of the wire. And that's how you know. And of course, you don't want to stick a metal tool around the outside of a wire.
The ones I saw were plastic, and I think the idea was that holding up to the insulation, you'd get a pretty close idea.
You would get a pretty close idea.
Just to know if you were within.
Right. And it should say on that wire, if you can't read it, you might just indicate that you think it's the right size, but should be checked by a qualified electrician.
Yeah, there we go.
Like so moving along, we have many problems in this panel. I've shown you a few in the entry. Notice this smaller wire, which is okay. It's okay to reduce the size of a neutral.
How much?
Well, that all depends on the code. So in this instance, this is a piece of 2/0 aluminum, which is fine for 200 amps for the neutral, because you're allowed to reduce the neutral down to 2/0. So that's okay, but it's not marked as a neutral. I don't know what that wire is. It needs to have white tape around it.
Does it vary by jurisdictional code, or by the NEC, or by the International Residential Code?
Does what vary?
The amount that this can be smaller. You said it varies by code.
By the National Electrical Code.
Okay.
Spell that very clearly in there. So,
So we have no marking showing that that's the neutral conductor.
that's correct. Contrarily, that's not a word. Ironically, here's a white wire, here's another white wire, here's another white wire, very well indicated as white, but they're not white wires. They're on a breaker. So they are hot. When this breaker is on, this white wire is hot. That's okay. You can use a white wire on a breaker, but you must mark it with black tape to indicate that it's hot so someone doesn't think it's a neutral wire.
What about somebody taking a black magic marker or a felt pen?
Electrical tape.
Okay.
All coding markings in a panel must be done with electrical tape.
Gotcha. So is that it for this area here?
Well, that's it as far as that area goes. Notice again, you'll see if you can see back in here, there's another bushing that's missing. And this, of course, can be a plastic bushing because you see there's no concentrics left around there like there is here. Everything is taken out. So that could be just a plastic bushing, but it's bigger than 1 inch and it needs to be protected.
But if it's not a plastic bushing, if it's metal, then it needs to have it should be a grounding bushing.
No, if there's no concentrics, meaning if there are no more knockouts available, then this lock nut can serve as a ground.
Oh, I see.
And will tie that conduit to the panel.
It's a permanent connection to the panel.
Correct.
What about, I don't see any antioxidant paste on these. Is that necessary?
Thanks. This is antioxidant paste, and any aluminum connection whatsoever must have this paste on it. And it's hard to see sometimes. Here's what it looks like. I'll put some on here. Sometimes it's gray, but sometimes it's clear in color. That's not where it goes. It's supposed to be back inside this wire. And it's used because aluminum oxidizes. And when it oxidizes, it heats and cools and loosens connections like these very tight connections now in 10 years could be so loose that you can pull this wire right out of here.
So does it also create an oxidized surface? So you've got a film of oxidation on the surface of the wire that degrades the connection also?
That's correct, which is saying essentially the same thing because it's arcing through that bad connection and heating and cooling and heating and cooling and loosening that connection. We're both saying the same thing, really.
You know, they did talk about some other things in a class I took on aluminum wiring, and one of them was thermal expansion and contraction, and another one was, is there a problem between the steel lug here and the aluminum there being dissimilar metals?
No. If the lug is rated for copper or aluminum, and it will say on the cover of the circuit panel, it will say ALCU rated, which means you can put either aluminum or copper underneath this, because this is actually an alloy of copper and aluminum.
So whenever you see aluminum surface entrance conductors, you should be looking for ALCU
Yes.
on the panel label.
And I would almost assure you that unless it's like 50 years old, any lug in a circuit panel is going to be rated for either aluminum or copper.
Right. I notice on some panels you can't see the surface entrance conductors. They're hidden to about there, and then you can just see a couple of inches of the bottom of the conductor. You can just see basically the lugs. And it looks like there's a permanent cover on that part of the panel.
Mostly that's on a commercial panel. I rarely see that on a residential panel. But this should always be removable if there is a cover on it somehow, so that you can see these wires. Because you really have to get to install it, you really have to get your hands in there.
Right.
So if that's the case, and I can't recall one off the top of my head, but if that's the case, that should be removable. You should be able to see those conductors.
Okay.
Some of the other issues in a main circuit panel, it is okay to combine on both of these buses. You'll notice that this is your neutral coming into the neutral bus, as we call it, and it is tied across the bottom of this panel to this other bus. Therefore, both these buses are neutral buses, and at the first point of disconnect, this breaker, you may combine grounds and neutrals excuse me, on the same bus.
This point, the point of disconnect is separate from these, so these aren't really at the point of disconnection, so I'm not sure what you mean by that.
The first point of disconnect, this is a disconnect.
Right.
This is the first point of disconnect on the main service. Next to this would generally, or right behind this, would generally be a meter.
Right, I wasn't sure what the connection between this being the point of disconnect and the bus bars was.
What the code says is, at the first point of disconnect, you may combine the neutrals and the grounds on the same bus bar. This is the main circuit panel. In other words, the first panel in the home, as differentiated from this panel, which is fed from this panel. This panel could be all the way across the house, but for convenience, we've put it right next to the main panel.
Right.
In the main panel, at the first point of disconnect, which is this breaker, you may combine the neutrals and the grounds on their bus bar, on the same bus bar.
So at the first point of disconnect, meaning this panel as opposed to another panel.
That's correct. Okay. If you'll look over here at the sub panel, you'll see all the white wires are connected to the white wire coming in, and all the grounds are connected to the panel itself and in their own separate ground bus bar. No connection between these two. I have more to show you in this panel later, but just to explain the difference, these two bus bars are connected across here, whereas these two bus bars are not.
Right. Gotcha.
However, I'll get to that later. Another problem with this panel, for example, here's a loose ground that's just hanging out in this panel. That means that that circuit is not grounded. It should be tied to this bus bar, and I just happen to see it loose in here. That would be something very important to notice. Here's another problem. Notice this is a hot wire coming off of a breaker, and it is skinned. You can see the copper on this wire. That's very dangerous. Should this ground touch this wire, you'll have an explosion.
So that's the sort of thing you should watch for. If one of the wires lays close to the edge of the panel, that's probably how it got skinned.
Well, it could be any number of reasons how it got skinned, but to notice that is very important.
Well, I'm just saying you might want to look at wires more closely if they're close to the edge of the panel.
Yes. Generally, this can happen when the wires are stripped from Romex down to wires. If an electrician is not careful in the way he strips it, he may cut into this wire as he strips it and not even know he did it.
Gotcha. So to back up just a little bit, if you see this here before you've checked the branch wiring in the house, you should actually be watching out for one that is
absolutely
missing the ground.
Yeah. And we will, when we look at these outlets down here, we'll look at various examples of that, what you will be finding when you look at the rest of the house. Another problem in here is, notice there is a piece of paper back in here just floating around in the panel. Well, this is combustible. And should there be a spark, that can ignite. And that's not a good thing to have anything combustible in a circuit panel. If you see that, that should be removed. Not by you, but you should call it out as important that it need to be removed.
Debris
Another
in the box.
problem, notice this white wire, and in this case it is a neutral wire. Notice it comes across the live bus bar right here. That is not legal. All wires, no wires, hot or neutral or ground, may cross the bus bar, because that could be a very dangerous situation. You've all heard, I'm sure, of double lugging, something very important to look out for. Notice on this breaker right here, there are two wires under one screw. The same thing behind it on the neutral bus bar is 2 white wires under 1 screw. That is not legal. That's called double lugging.
Is it ever all right for breakers to be double lugged?
That's a good question, because I'm going to contradict myself. Yes, it is okay in a very limited situation for breakers to be double lugged, just like that. And what is that situation? The situation is where the breaker is rated for double lugging. The only way you're going to know that is in the tiny little writing on the breaker or on the circuit panel that the breaker is plugged into. It will clearly say breakers are approved for double lugging.
So will that be, that would then be all of them if it said it on the panel? It wouldn't be just one?
That's correct.
Okay.
It would be for all the breakers. And then also on the main lugs, it will state the main lugs are suitable and approved for double lugging.
Under what conditions would they double tap the main lugs?
If you're paralleling wires, if you're running a service, sometimes services are so big that you can't bend and move wires much bigger than this. So they run 2 of these, which is the size of 2 4-aughts. And they'll double lug them under a breaker if it's approved.
Yeah.
If it's approved.
Gotcha.
Sometimes they'll just have 2 lugs right next to each other tied together, which is, of course, approved.
What amperage service might that be?
400, 300. And you will more often now see that in a home. People are using much more electricity than they used to use.
Yeah. Is anything more about the bus bars here that we need to be looking at?
Well, here's another, not only an example, there's 3 problems with this right here. There's double lugging. There's also wires stripped. These are hot wires. They are stripped. You'll notice you can't see any of the conductor material on any of these breakers. However, on this one, it's stripped back about 1 inch. That's very dangerous, not just for hands in the panel, but knocking against other wires. So these should be, you should never see conductors that are exposed like this.
Is there,
I'm sorry, go ahead.
Oh, I just wondered if there's a minimum.
You just shouldn't
or
see.
a maximum. No, shouldn't see
I
it at all.
mean, you know, if you see 1/8 of an inch or 1/4 of an inch, you can call it out or not.
I often
But
see
when
that,
you
but-
see something like this is a full inch to 1.25 inches. In addition, this is 2 dissimilar wires. This is a piece of aluminum, and this is a piece of copper. And they are double lugged under the same screw. I just pulled this piece of copper out of here because generally when you have 2 wires of a dissimilar nature, aluminum and copper, under a double lugged under a breaker, it will loosen. That dissimilar metal will loosen that connection. As you can see, we pulled that right out of there. Let's talk about bonding for a moment.
Bonding? What's that?
Yeah, it's a confusing term. Bonding essentially means joining 2 conductor elements like the ground and the neutral. When you bond the neutral, the white wire, to the ground, that's called bonding. There are a number of ways to do that, and you should be in a main circuit panel at the first point of disconnect. It is, as we've discussed before, essential that the grounds and the neutrals are bonded to each other. There are many ways to do that. There is often a green screw in the circuit panel that goes through the neutral bus bar and ties that bus bar to the panel, to the can.
So that would actually be bonding the bus bar to the panel itself rather than bonding the 2 together. I guess those are bonded by the
Well, they
the
are
jumper bar.
bonded together right there.
Yeah.
But essentially, this panel is not grounded until this bonding screw goes in. That's what this green screw does. It bonds the metal parts of the circuit panel to the ground conductor, to the grounding conductor.
So if I'm just walking up to this as an inspector and I'm looking for the ground, I guess the first thing I look for is a green screw. Is that right?
Well, if you're looking to see if this circuit panel is grounded to the grounding electrode, grounding conductor, then you must find a screw like this, or often you'll see something like this, which is a little belt of metal that is tied to the circuit panel and then tied to the neutral. That bonds the neutral to the panel. Now, in this particular instance, since we're over here at the sub panel, that's illegal. These are supposed to be separate. This panel, this metal can of this panel, is grounded via this ground bus bar, which is screwed right into the panel. This neutral is not allowed to be. It needs to be, it's called floated.
Right.
This neutral needs to be floated from the ground and not connected. So essentially, what needs to happen here, this metal strap comes with the circuit panel, but it should not be used if that panel is a sub panel.
And often you'll see them with a strap there, but it won't be connected, so that it can be used for either kind of
You'll
panel.
see the strap just hanging out like that. That should be an indication that this is a sub panel and not a main panel. If it's a main panel and you see this, that's a problem. It should be bonded, just like this is with a green screw, or like this.
Sometimes in looking at a main panel, you might not see a green screw, but there still might still be bonded. It just might be bonded with a screw that's not green. And sometimes the label is missing, so you don't really know where to look because they vary from one panel to another.
Well, what some people will do, it should always be a green bonding screw. Actually, no other screw will fit in this hole and bond this bus to this panel without the factory-made grounding screw. But if you lose it when you're installing this panel, which I have done, you may put a grounding lug on the panel itself and then run a wire of suitable size, which would be number 4 or number 6, from that lug over to the bus bar, and you can look for that, and does the exact same thing.
So you're either seeing a green screw, a screw with a green head, or you're seeing a bonding strap of some sort, or wire.
Or one that we've created because we lost the screw. Yes.
And if you don't see that, it's not bonded.
Only in a main panel. First point of disconnect. Over here, you won't see that.
Right, yeah, in the main panel, the main panel is not bonded if you don't see that. David, sometimes I see panels, like the other day I looked at a Siemens panel that had breakers in it that said ITE. They seem to fit fine. Is that all right?
That's a good question, because many breakers will fit in many panels, but you're only allowed to put the breakers in a panel that are made for that panel. For example, in a Siemens panel, ITE breakers will fit, and they're fine because Siemens and ITE are the same company. However, if you see, this is a GE breaker, if you see this in a Siemens panel, there's a problem. If you see a home line in a Siemens panel, there's a problem. It will state on the cover of the panel what breakers you can use in that panel.
So there might be 2 or 3 different listed that would be okay.
There will actually only probably be one, and it'll be a letter, QO, QP, etc., that will describe what breaker can be used. Let's look at this panel. This is a GE panel, okay? And if we hold this up, it'll tell you that, I think it'll say THQP breakers are the only breakers allowed in this panel. And here we go. So for 10,000 RMS, this is more than you need to know, which is what residential services are rated. These are all the breakers that can be used in this panel. Here's a warning right on the cover that says use only GE type breakers. Use of other circuit breakers voids the warranty, and worse than that is a danger.
I just wondered what other kinds of conditions inspectors will run into with other panels.
Well, we have one right here. This GE panel is filled with GE breakers except when you get down to here. These are ITE breakers. They fit just fine. You can barely tell that they're not GE breakers. Notice GE breakers are a little wider than the IT breakers. They are not approved to go in this panel.
Is that a fire hazard?
It is. There's another problem in this panel that you'll notice. This is a 50 amp breaker. A 50 amp breaker needs a 50 amp rated wire coming out of that breaker, or else there is a hazard of fire. This wire is a number 10 wire. It is only good for 30 amps. So therefore, this is too small a wire to go on a 50 amp breaker.
So it could be larger, but it can't be smaller?
It can be larger, although it's not advised that you even do that, but it's safe to do that, because down in the house, if this number 10 wire is under a 20 amp breaker, which is fine, it's not going to be a fire hazard, someone on the other end may think it's under a 30 amp breaker and think it's suitable for 30 amps, hook a dryer up to it, hook a hot water heater up to it, and it wouldn't work. One other item on here, if I can mention, is that all 220 breakers, which are double pole breakers, like these, having two hot wires coming out of them, are tied together. These are breaker ties that are holding those two breakers together. Notice down here, this is also 220. This is one piece of Romex with an unmarked white wire. It should be marked black with black tape, as we talked about before.
What's 220?
These two wires have 220 volts between them. One hot, 220 volts between them. However, this breaker, these two breakers are not tied together like all these other 220 breakers. Therefore, you can turn one of them on, and this breaker may be hot if it's going through a piece of equipment that ties the two phases together.
Why is that 220?
Two phases. One phase of 120, another phase of 120, which is the same as these two bus bars here, which is every wire is a different phase. A phase, B phase. A phase, B phase, A phase, B phase, A phase, B phase.
But these aren't tied together like those. So
that's correct.
What makes those 220?
Because they have an A phase and a B phase. That makes them 220.
I'm confused. I mean, you've got a number of breakers here.
But these are separate pieces of Romex with a neutral. These two wires go to the same piece of Romex right here. They go to this piece of number 10 Romex. So this white and this black are both hot. And therefore, this is a 220 wire. This is carrying 220 volts somewhere in the house.
So, in order to determine what's 220 and what's 110, you've got to follow them all the way up to the point at which they come through the bushing?
Well, if you see a wire, a white wire, even if it's marked black, and a black wire, and you determine that they come from the same piece of Romex, they should be on a breaker that's tied together.
So you need to follow them back to see if they're coming out of the same piece
correct.
of Romex. Okay.
That's
so
correct.
Does that mean, in order to ensure that everything is correct, and the inspector needs to follow each one back?
No, because if you just see a simple black wire going to a single pole breaker, then you know that there's a white wire that's going to be going to this neutral bus. So it's a 120 volt circuit.
Okay, so it's either miswired with a white wire where there should be a black wire, or it's a 220
That's correct.
circuit. Gotcha.
So moving over to the sub panel, which the first thing I notice, and this is important because you'll notice how this sub panel is not flush with the finished surface of the wall. It's set back. For a number of reasons, that's a problem. One, if there should be a spark of some kind in this panel, there's wood right next to it here, and that could cause a fire.
This one is back about 1/8 of an inch. As long as there's no, is that a problem? As long as there's no wood showing?
I mean, that's very picky, but it's supposed to, what the code says is it is to be flush with the finished surface. So technically, is that wrong? Yes. Absolutely, this is incorrect. Not just because of the fire hazard, but when you put the cover on this panel, you'll notice that the breakers are so far away from the cover of the panel that you can barely reach them.
Yeah.
Okay? Also, if you see a situation like this in a panel where there's openings and no breakers in there, that's a very dangerous. Some little kid could just stick their hand right in that panel.
Or if they're covered with electrical tape rather than blank.
There should be knockout fillers, blanks, covering these spaces if there are open spaces in the panel. We noted before that the neutral was grounded. We took that ground wire, that grounding strap off of the neutral. Now this is wired properly, where the two hots, the 220 volts, come to the hot bus bar, and all the grounds come to the ground bus bar. All the whites come to the other bus bar.
I've been in buildings that were condos, condominiums, and seen main disconnects with a grounded neutral bus bar, and been in other units that were that had a floating neutral. So, do you have to find a meter outside that single unit to ensure that it's a main panel rather than a sub panel?
Well, and this was condo units?
Yeah.
As a rule, and no rules are fast and furious. You go into a condo unit where there are a number of apartments, that means that the main service is far away from each one of those units, meaning there's a meter and a disconnect somewhere out by the road or out by where the power comes in. That means that even though this panel that you're looking at may look just like this, it probably is a sub panel, because the first point of disconnect will be all the way out at that meter where there is a shutoff.
So the fact that there's a main disconnect has nothing to do whether it's a main panel or not.
That is absolutely correct.
So
that would be a redundant disconnect, which is fine. That's a good thing to have in an apartment. If you were in an apartment and you had an electrical problem and you needed to shut the power off, it's great that you have a main disconnect. As a matter of fact, any situation that takes more than 6 throws of the hand, in other words, if there were more than 6 breakers, and this counts as 1 throw of the hand, if there were more than 6 breakers, you must have a main disconnect. Because they don't want anyone to have a problem. If they have an electrical problem in their house, they don't want them to have to make more than 6 moves to get all the electricity shut off in their house.
David, does a sub panel have to have a main breaker?
No, it doesn't. You'll find many sub panels without main breakers. As long as there's a breaker in the main panel that feeds the sub panel, this sub panel can have any number of breakers, up to 40 breakers.
So what's the rule with the 6 hand throws when it comes to sub panels?
At the main service, you must have no more than 6 throws of the hand to cut power to any one building. So if you have, for example, let's just say 8 circuit panels in one condominium, and they're all fed from one breaker panel, and that breaker panel does not have a main breaker but has 8 separate 220 amp breakers to feed all those different panels, you must have a main breaker.
David, in a condominium, how do you tell a main panel from a sub panel if they both have main breakers and there may be a main panel located remotely somewhere that you're not going to look for?
Well, I can't answer that question. The truth is, you have to discover that. The only way to do that is to find the main entry service of the condominium and note whether there is, in fact, a main panel. Generally, when you're in a condominium building that has 8, 10 apartments, any individual panel in any individual apartment is not going to be a main panel. It's going to be a sub panel because it's going to have, you're not allowed, you must have a breaker in front of the wire that feeds that panel to that condominium.
So I guess about the only other clue might be if there's a meter outside the back door.
Yep.
Yeah.
Yep. The important distinction between main panels and sub panels is where is the meter. If your panel is your main panel is more than 6 feet from a meter, there must be a disconnect between that meter and that panel. So if you're in a condominium and the meter is 20 feet away, there needs to be a disconnect between that meter and that panel. So therefore, that panel should be a sub-panel with a floated neutral. However, if there is no shutoff between the meter and that panel that's more than 6 feet away, then you should be calling out that there needs to be a disconnect between the meter and what would then be the main panel. Once you put that disconnect in, that main panel would become a sub-panel.
So that's why you often see outside the home, you'll see a meter with a single disconnect there, and then the rest of the circuit breakers are inside the house where they can get to them in good weather without having to come out in the snow.
And that would be a sub-panel. Even if it's right next to that main breaker, it will now be a sub-panel, and the ground and the neutral need to be floated.
Are there ever any conditions in which there might be, like on a rural property, you'll have a telephone pole or a post of some sort out in the yard, a utility pole with a meter and a disconnect, and then at the house there'll be another main panel, another main disconnect?
Correct. All the time you'll see that.
So you can have two main disconnects?
You can. We're talking about the same building. So if there is an isolated disconnect, say out by the road by a transformer where the meter is, on a pole separate from the house, when you get to the house, that panel is treated as a main panel. It will not have a floated neutral. The first point of disconnect in any building is the main panel.
Would you like to tell us something about labels?
Well, you know, you'll come across this a lot, and this is a very dangerous situation. Notice this panel cover. There isn't one label on it as to where these circuits go. So, for example, if any of these breakers go to a bedroom, there is a code requirement that that bedroom be supplied with an AFCI breaker. Well, how are we going to know which one of these breakers is a bedroom breaker when it's not even labeled on the circuit panel?
That's a modern requirement. So we looked at a lot of houses that are old enough so that wasn't a requirement when they were built. What's the cutoff date, and how does an inspector know what to call when he comes into that situation?
Well, the cutoff date just for AFCI breakers is about 2005. So you're not required in an old house to put AFCI breakers on all the bedrooms.
I guess it would be a good idea for an inspector to mention that new homes do have that requirement, and that it would be a good idea to provide it for older homes.
Just as inspectors call out the fact that kitchens are supposed to be GFI protected when many old homes don't have kitchen or bathrooms that are GFI protected.
on this label, in addition to no circuits being labeled, there's no amperage written down here. And if an inspector is looking at a main panel and there's no amperage printed on the label itself, and no one has written it in, how can an inspector tell what amperage the panel is?
Well, the easiest way is the main breaker is usually labeled to tell you what size that breaker is, which tells you the size of the panel. It's a 200 amp panel with so many spaces. However, if you don't see that on this cover, there's a very inconvenient place to find that information, which is underneath, usually on the side portions of the panel, there is labeling which will tell you, and I can't even get to it, it's really a pain in the neck to get to this labeling to see what the rating of the panel is.
A lot of times it's covered up with wires, and
it's always covered up with wires.
So if you want to see it, you need to stick your fingers in there, or something non-conductive in there, which is a bad idea.
Remember the gloves.
Yeah, inspectors are not supposed to put anything into the panel according to their standards of practice. I imagine sometimes, even though the disconnect may be rated at 200 amps, the panel might be rated at something else. Is that right?
I think what you're talking about is the bus bar of the panel can be rated, is always rated at the size of the main breaker.
So is the panel itself? The panel itself is rated according to the amount of heat it can withstand. Is that right?
It's fire rated. That's of a different code. But yes, it is fire rated to contain any fire that's in that panel.
So is there a rating, an amperage rating for the panel itself that's separate from the bus bars and the disconnect?
No, there isn't.
Okay, so what you're reading on the label is actually the amperage rating of the bus bars.
That's correct.
Okay.
A couple of things. One thing I forgot to point out is all these wires up here are protected where they come in through the outside of the panel. If you'll notice, there's a wire back here, this black wire, coming through a knockout in the top of the panel with no bushing of any kind. That's a very dangerous situation. All wires coming through into the panel must have a bushing of some kind to protect that wire from the sharp edges. Also, any openings in the panel that don't have a wire in it or don't have some sort of that don't have anything coming into the panel through it need to be closed off. Notice in this panel there's an opening in the back of this panel that just goes out of the panel. So anyone can stick their fingers in, or anything can come in through that panel, maybe even a small critter of some kind. You never want to have openings in a circuit panel.
What about the holes for hanging it? Those are about 3/8 of an inch?
Those are fine.
Okay, so there's a cutoff somewhere around 3/8 or half an inch?
Well, those are just made at the factory for the panel.
Right.
These are punched out by the installer, and if they're not used, they need to be covered. I want to show you one other thing which is difficult to notice sometimes, and that's overheating of wires. A great example is this 20 amp breaker right here, and in that 20 amp breaker is a wire that is undersized for a 20 amp breaker. This is a piece of number 14 wire that can only be inserted on a 15 amp breaker. However, someone has put it on a 20 amp breaker. What happens when you do that, if you can get a close-up of this, is that wire can become overheated from use, from having too much electricity flowing through that wire, and it's not rated for that much electricity. It's not rated for 20 amps. However, and this is what happens, the wire starts melting. This is a very serious fire hazard. This can happen at both ends, in the walls, anywhere along the route that this wire takes if it's under the wrong sized breaker.
So an easy way to tell the difference between a 20 amp a wire rated for 20 amps and one rated for 15 amps be to maybe squeeze it and see if you can bend it, how hard it is to bend?
Oh, you really have to have a feel for 14 and 12 wire, and that doesn't take very long, but I can tell just by touching this wire that it's 14 wire, and I can tell by touching a 12 wire, which I'm not finding one.
Over there.
Here's a 12 wire. It's just thicker and it's stiffer, and you just get the feel for that. What you can always do if you want to find the size of a wire is you can take it off the breaker, and you can take your strippers, and you can see if it fits on the 12 or the 14. Notice it will not go into the 14 hole.
Inspectors typically aren't going to carry strippers, though, so we're just looking for more. I guess they pretty much go by feel and how easy it is to bend, huh?
Difficult thing to do. I don't know that that's...
That's just what I do, and
does it work?
Yeah, it works really well. You can take a piece of 14, and if you use 3 fingers, you could bend it fairly easily, but 20 doesn't bend nearly as easily.
Okay, that's a good plan. I don't know. It's not very scientific, and it's not very conclusive. It's a little subjective.
David, what about aluminum wire in the panel?
You'll find some back in the 1960s, somewhere between 58 and 1970, contractors were able to save a couple of $100 in wiring an entire house by using aluminum branch circuit wiring. It is now illegal, cannot be. So you won't find any in a more modern home. But in some of the older homes you'll inspect, you will look in a panel and you will see a clear distinction between copper and aluminum wire. And when you see aluminum wire, it's very important to call that out to the homeowner, in the inspection report, to call that out as that you have noticed aluminum wire in the circuit panel. Now, having said that, often your service entrance conductors are aluminum. We still run aluminum wire for larger circuits like ranges, sometimes dryers, and that's fine. That's legal. So where you get into trouble is anything smaller than a number 6 wire is not allowed to be run in aluminum.
If you see that in an older home, is it a defect, or is it just something that needs to be well maintained?
Well, it's something that needs to be, if it hasn't been repaired, there's no way to really fix aluminum wiring by pulling it all out of an old home. That would be cost prohibitive. But what it can be is at every location throughout the home where that aluminum wiring is, it can be repaired. We'll talk more about that when we get to talking about the outlets, because I'll talk about repairing aluminum wiring. But in a circuit panel, your main job is to notice that there is aluminum wiring, and then later when you find an outlet to see if it's been repaired properly.
Gotcha. So we have stranded wire on the service entrance conductors. What if we have, say, stranded copper wire in here? Is that acceptable?
Oh, yes. Stranded copper wiring is fine. No difference. And they in all sizes, from 14 all the way to as big as, this big around.
Yeah.
You have stranded wiring, and that's fine. You wouldn't be able to bend it if it wasn't stranded. And some applications require stranded wire on lighting fixtures and for certain installations. But it's fine to put them underneath one of the screws in the circuit panel.
Does that include the grounding conductor?
That does include the grounding conductor. What you want to watch out for in terms of stranded wire is occasionally you will see a wire that is too big for example, if this wire someone tried to put this 4/0 wire in this smaller lug right here, they would have to trim that wire in order to get it into that lug. You would see that because there would be all kinds of strands that are cut back to make it smaller and to fit into this smaller lug. That is not acceptable. You're not allowed to do that.
We definitely do see that occasionally.
And that's something to call out, that a wire has been modified to fit into a lug where it doesn't belong.
Dave, you're going to take us through some of the tools an inspector could use to inspect an electrical panel and some of the safety measures.
Okay. Before you even inspect an electrical panel, it might not be a bad idea to take an induction tool, and I'll show you a number of these, and just test the panel to make sure it's not hot. If you hear that noise, you know that the panel is. So if you're using bare hands, which I never use, I always do electrical work with gloves on, then when you grab the panel cover, you will not get a shock. And of course, most people are very, very important to most people. So we take this.
So I suppose if you did find that it was energized, you'd let anybody in the house know, and would you tag it? Or?
I would tag it. I would not let anyone near the panel. I, frankly, have never run into that situation, but it is possible. It could happen. So if I found that the metal parts, any of these metal parts of the panel were energized, I would stop right there and wouldn't let anyone near that panel until you called a qualified electrician.
Right. We might as well start with the closest tool that
well, this is probably one of the most important when you're inspecting and when you're looking in panels, just in case there's a short circuit of some kind that will cause a flash. These are safety glasses. Very important. Protect your eyes when you're in a circuit panel.
I notice you're a lot more comfortable sticking your hands into the panel than most inspectors are.
Oh, well, if you have gloves on, there's no problem sticking your hand into a panel. If you have good gloves on, you can touch all these wires I'm touching are hot. This is the main service coming in. It is hot. Now, if I were standing in a bucket of water and my gloves are dry, no problem. But if these gloves ever get moist, of course, that's a conductor of electricity, and you will get a shock.
Are those rubber palm gloves?
These are not, but they're a very strong leather industrial glove, and it is recommended that you use rubber gloves when you're dealing with electricity. However, these are very protective, and they work just great. I see you cringing.
I am cringing, yes.
This is a great tool to get used to, especially when you're dealing with outlets and switches. It speeds up your job. Here's another speed tool. This is a cordless screwdriver, and this bit pulls out very easily. It actually pops out if you're not careful. And on the side, there's a Phillips and a regular screw tip to take panel covers off, take outlets out, and you can get a variety of tips for any use.
Might be a good idea for inspectors to carry a few extra cover screws around too, since you tend to drop them into window wells, into snow, and
well, that would be that. They are very available, and they're industry standard. All panel screws for all panels are of this particular thread. And yes, you drop a lot. Another thing you come into contact with is often you'll come to a circuit panel which only has one screw in it, or two screws, and you need 6 of them. So that would be good to have.
Occasionally we see deck screws that are 2 inches long put in there also, which could come into contact with energized components inside the
It is very clear in the code book, and this would be a good thing for any inspector to call out, is you must have a flat-headed screw and not a pointed screw going, I don't care if it's 3 inches long or 1 inch long, should never go into a circuit panel, because here's a hot wire right behind it, and you screw that in tight. This screw has got a flat surface. It will still nick that wire if it's done improperly, but it's a lot less likely than if you have a wood screw type sharp screw going into that, and that will cause quite a spark. Great time for those safety glasses. So there are a lot of tools to test electricity, and so they all have their purpose, but some are better than others. This tool is an induction tester, and it will test hot wires versus wires that are not hot. This is your neutral. It should not be hot. This is one leg, one hot leg. This is another hot leg. Between them, you've got 240 volts.
And it's a very common tool for inspectors to carry just because they go into attics and crawl spaces, see abandoned wiring hanging down, and want to know whether it's hot.
Great advantage. However, this tool right here is even better because it does it all. Not only does it do the purpose of this tool by just holding this in, I can test hot wires, okay, and dead wires. So it does that. But more importantly than that is it tests accurate voltage.
What's this called?
This is called a Wiggy. This is a particular brand of Wiggy, but in the industry we call it a Wiggy, which is a voltage tester. It comes with protected leads, and these leads, so when you might get a reading with this tool, but you have no idea what kind of voltage you're dealing with. That could be 60 volts, 70 volts, 80 volts.
So these are the service entrance conductors. How would the voltage vary?
Well, if the power company is delivering improper voltage, you'll have no way of knowing that. If there is, for example, a loose connection beyond this, before this point, or a loose connection down the way, you can see the difference between the two. So this going across the two hot wires will show that this is a 208 volt panel. And that means that everywhere down the road, when you go across, when I say down the road, I mean down the line, electricity further, you should always get this 208 volts.
So down anywhere
downstream.
Thank
you. That's a great word. Downstream. So if you can see this meter, the first is 24 volts, the next is 120 volts, 208 volts, 240, all the way up to 600 volts. So this is telling me we have 208 volts. Now, you won't run into that very much unless you're doing a commercial building inspection. This is a commercial building and a commercial panel, and very frequently you won't have 240 volts, you'll have 208 volts.
So it's the last light that's lit that tells you
correct.
the
last light that's
voltage.
lit
Okay.
will tell you the voltage.
So that's the Wiggy. What have we got in this case, David?
Oh, this is my, to be even more precise, because occasionally when you're dealing with very sensitive equipment, you really need to know the exact voltage. This is adequate to tell you whether you have 240 volts or not, but this will tell you down to, you know, a fraction of a volt, how many volts are being put out by the power company or in this panel.
What kinds of situations might require the increased accuracy that this tool gives you?
Well, there are a number of applications for this tool. This tool, as I said, is more precise, but it also has more functions than this tool. This reads voltage, reads induction. This also reads voltage and reads induction and reads continuity. This also reads continuity, which means that if you want to see if there is continuity between two wires, all you have to do is touch these two together. It will shake in your hand and will also beep. Same thing here. If you touch these two leads together, you'll get a resistance reading in digital, a digital resistance reading that...
So why am I touching these two wires together?
Because you want to know, for example, if two wires are...
So we're not touching these two wires together, we're touching two wires.
No. Well, we are. This, you always want to test a meter before you use it. So this, when you touch this together, will zero out. and thereby, which it's not.
So that's a calibration method,
'cause
basically.
It's a calibration unit.
Okay.
So this may be a little more sophisticated than you want for inspection purposes, but in a commercial inspection, often you'll need to know oh, I'm not on voltage. You'll need to know exactly how many volts you've got coming into the building.
And this is called a digital multimeter?
This is called a digital multimeter. And of course, it's the most expensive. So, as I showed you before, my meter read 208 volts coming into the building. Well, the actual voltage coming into the building is 203.8. So you might need to know that if you have some very sensitive equipment that will only operate in a parameter of 206 to 209 volts, and you feed it with 203, you might ruin a very expensive piece of equipment.
What's the difference in cost between the multimeter and the Wiggy?
Well, we can go all the way down to this piece of equipment right here, which you can get for $10 to $15. And then you move up to the Wiggy, which is more along the $70 range. And then you move into a digital multimeter, which you can spend anywhere from $200, $250, all the way up to $600 or $700 for a very specialized. But this tool right here cost me about $200.
So is it necessary for a home inspector to have a digital multimeter?
I'd say not. I would say a commercial inspector who's inspecting a building filled with motors and equipment and sensitive computer equipment might want to have a piece of equipment like this. However, I would, as an inspector, always have a Wiggy because these two tools, although very helpful and very useful, are not sufficient to do a proper inspection.
So would you use this only, or would you use this in addition to these two testers?
There's applications for each, and yes, I would use this in addition to these two testers. This tester is deceptive, and it has a very important use. For example, if you're up in an attic space and you're looking at what's known as knob and tube wiring, which is a very old-fashioned kind of two-wire system in a house, and you need to know which wire is hot, and which wire is the neutral wire. It's also known as the grounded conductor. The only way to tell that is with a tool like this. If you're up in an attic or down the crawl space, you want to know where the hot wire is. That will tell you which is which, because they're invariably not labeled.
So if you see abandoned wiring hanging down in the attic or hanging down in a crawl space,
exactly, is that wire hot? You know, you wouldn't have to strip the wire in order to, use this tool. However, as I said before, this tool also has an induction sensor in it and does the same function as this, but look at how small and convenient this is. Look at how great this is to just stick in your pocket and crawl up in an attic.
I've noticed that the induction sensors will pick up static electricity. In other words, I've held it up to a wall that had no electricity in it, only it was on the downwind side of a barn, and it went off.
That's great.
Good
point.
Is the Wiggy, will the Wiggy avoid that problem?
It should.
False readings?
Well, they will both give you false readings. The Wiggy will give you many less than this. This will give you, I've seen this, put this up to my ear at times, and I do work with a lot of electricity, so it is possible I might be charged. However, I've seen it go off in many a situation where there's no electricity, as you mentioned, and that's very important. You cannot trust this tool 100%.
Any more tools that you'd like to show us about, David?
Just a few basic tools I think would be important. Of course, you'll need just your standard, everyday flathead screwdriver. Perhaps you'll need a Phillips head screwdriver.
Do you use a four-way? The kind you just flip the...
No, I do not, because I like to have a firm, insulated grip to all my tools. A lot of those, when you have to pull those out, get lost, they're not really stable. I like a lot of stability in the tools. I don't want to be slipping off a screw into the wrong place. So I don't use those. Now this is a tool that I call it a squiggly. And what it does is, it's just a speed device. It's called a speed screwdriver. So with this screwdriver, you could take screws out and put screws in very rapidly. Great for taking apart outlets.
Without having to carry around a cordless that
Without
needs a battery.
having to carry this big cordless that needs a battery. So this is a very good tool. And another essential tool is a flashlight. Sometimes you really have to see in corners and places in order to see problems. You need to get up into places, and a small, very bright flashlight is an essential tool for an inspector.
In some panels, you have a lot of wires in there, and the only way you can see the bonding screw or the bonding strap is with a really bright flashlight.
That's true. And that's a very important call, is a bonding screw, to see if a panel is bonded.
So David, we all know that water conducts electricity, and a lot of us are inspecting in climates where it snows, and a lot of main panels are outside. So what are the dangers if you walk up to a main panel outside and you have to stand in 2 feet of snow to work on the panel?
Well, even worse than snow is wet ground or rain, but snow is also a good conductor of electricity. One of the rules that I always adhere to is, in a circuit panel, if I'm not wearing protective gloves, I will never have more than one hand in a panel at any time. Okay? So when you have two hands in a panel, and imagine that I had no gloves on, if I'm across two terminals or get electricity from a hot wire to a ground across my heart, it could kill me. So that's why I always keep one hand behind my back when I don't have protected situation, and then all I feel is a little, oh gosh, that's hot, you know.
One thing they tell us is that you stand on your right leg and you use your right hand. That way the electricity goes through the right side of your body instead of through your heart.
Well, that's very true. And who's going to remember that
I
at
do.
all times? Do you remember
Yes,
that?
I do.
Yeah, after all these years, I don't remember that.
And you wear gloves.
And
so.
I wear gloves always.
I think that covers it for the main panel. David has made some changes in the sub-panel for us to take a look at. What's new here, David?
Well, I put a couple of breakers in here because in the new code, the 2008 code, you're going to come in contact with a lot of these breakers right here. And as always, you'll come in even greater contact with these breakers right here. The reason being that in the new code, virtually every circuit now in a new home must be protected by either one of these breakers, which is an arc fault circuit interrupter breaker, or one of these breakers, which is the old GFCI breaker. Now, once again, you don't always have to have a GFCI breaker in the circuit panel. You can lead a circuit with a GFCI outlet and feed a number of outlets off of that outlet, and that will protect the circuit per code. So you might see this in your circuit breaker panel, but you also might not see this, just to see a regular breaker and see a GFI down the line.
So this will protect all the breakers downstream.
All the devices downstream from this device.
Right.
And so will this.
What other kind of device besides an outlet might it protect?
Lights. It could be on a particular outdoor lighting circuit that the entire circuit would need protection. It could protect an in-shower light if it needs to be protected. That's not, doesn't have to be, but if it's deemed to be protected by ground fault, it could protect lights, plugs.
So there are other devices besides outlets that need GFCI protection.
That's correct. Any wet location that's subject to dampness would need to be protected by a ground fault circuit interrupter. Good example of that would be in a shower. Sometimes it's impossible to have a light in a shower without having that switch within reach of the shower. So you actually could physically be in the shower, getting wet, reach out of the shower, and turn a switch on and off. That could be deemed allowable by the inspecting agencies, but certainly it would have to be ground fault protected.
And we do see that from time to time where they're just a foot or two outside the shower, or
Right.
you can reach them from the tub, that sort of thing.
Right.
So we need to be looking to see in the panel to see if that's connected to GFCI.
That's correct. The only way that's okay,
Gotcha.
and even that's marginal, that's up to the inspector. The inspector can say no. But if the inspector deems that okay, that it would have to be GFCI protected.
So I'm sorry, I hadn't realized that all new homes, is that starting in 2008, have to be protected?
Starting wherever the 2008 electrical code is adopted. There's been a lot of controversy with that code. So far in our community, Boulder, Colorado, it has not been accepted. They say it will be accepted January 1, 2009. So, but already it's been accepted in the state of Colorado as of August 1st. So throughout the state where you're getting inspected by a state agency, all circuits in a house, every one, must be protected by an arc fault circuit interrupter unless it's a circuit that needs to be protected by a ground fault circuit breaker. And because you cannot do both. You cannot protect both arc fault and ground fault at the same time. So bathrooms, kitchens, outdoor outlets will all be protected by a GFCI breaker or outlet, while every other circuit in the house, bedroom, living room, garage, etc., will be protected by an arc fault circuit interrupter.
When did the code go into effect that bedrooms had to be protected by AFCIs?
In the last code cycle, which was 2005, all bedrooms had to be protected by arc fault, and every electrical device in a bedroom had to be protected by an arc fault circuit interrupter. Lights, plugs, smoke alarms, fans, etc.
Gotcha. David, I heard something about a problem with AFCIs using a shared neutral. Can you talk about that?
Yeah, I have an example here of that, and let me explain first what a shared neutral is. A shared neutral is when you have a home run, meaning circuit that goes out from the panel, when you have a home run that has one neutral but two hots. Therefore, these are two circuits, and they must be on separate phases, A and B, coming out of the circuit panel, and it's fine to share a neutral. Why is that? Well, because this neutral, and this may be more information than you want, because when you share a neutral between phases, you cannot overload this neutral more than 15 amps, which is what it's rated for. If you share these on the same phase, you could conceivably put 30 amps on return with this neutral, and that could melt this neutral. So when you have a shared circuit, and this is something to look out for when you're inspecting a new house, and you see a shared circuit like this, well, they must be on separate phases in this bus bar. And I'll take these breakers out just to show you how this is one phase which picks up half of the circuit panel, and this is the other phase which picks up the other half of the circuit panel. So when you see a multi-wire branch circuit, red and black, with a shared neutral, they must be on separate phases. However, long way around to answer your question, The AFCI cannot share a neutral with another circuit because it will not stay, it will trip. So you may not use an AFCI on a shared neutral circuit. All that having been said, they are coming out with a breaker, apparently, to meet the new code, that you can use a shared neutral multi-wire branch circuit, but it has to be a specially approved AFCI breaker to do that.
I inspected a house about a year ago, and it had 3 bedrooms. I guess it was 2 years ago, and that would have been 2006. And it had the bedrooms on AFCIs, and I had a lot of trouble getting the AFCIs not to trip. I mean, I opened the panel, and they were both tripped. The superintendent was there. He came over and he had to reset them about 3 times before they stayed. And I'm wondering if sometimes they're just touchy, or if there was miswiring that I didn't catch.
No, you missed nothing. This is a big problem with arc fault circuit interrupters, especially in the early years, which was 2005, 2006. There was tremendous amount of nuisance tripping. That's why everyone in the new code is not only surprised, but up in arms over the fact that now the entire house has to be AFCI protected. These are very prone to nuisance tripping.
Even now?
Even now. They claim to have fixed them, and the manufacturers, they've claimed to have fixed them. They've claimed to perfected them. However, I got to tell you, there's still lots of nuisance tripping going on, but it's better. So maybe in the next generation, they'll be even better. But I'm not surprised that you found that problem. We have had, you can see I've torn all my hair out having to deal with AFCI breakers.
Yeah. GFCIs are a little bit better as far as nuisance tripping,
yes.
I guess.
But in their early days, they were a problem just as well. So patience and a lot of cost to us electrical contractors, and perhaps these will perfect themselves as well.
So what about older homes that have ungrounded systems, just 2-prong outlets, and what about recommending installing GFCI outlets on circuits?
The only reason one would do that is because by code, if you put a GFI outlet at the beginning of a 2-wire circuit, meaning you don't have a ground, you only have a hot and a neutral.
Right.
So if you put a GFCI outlet at the beginning of that circuit, then every outlet downstream can be a 3-wire outlet. The reason people are frustrated with 2-wire systems mostly is because they can't plug anything with a 3rd prong into the outlets anywhere in the house.
Isn't it a safety issue, though?
Well, that's a matter of opinion. By code, what I just described to you is legal. I recommend people never do that because I don't believe that it's safe. It's still a lie. When you see a 3-prong outlet, you're expecting this 3rd prong to be a ground. It will never be a ground when there's only 2 wires. So it won't even, a ground won't even trip that GFI breaker.
So it provides a false sense of security?
It provides, in my opinion, it provides a false sense of security. But it's better than what a lot of people do is they just take out these 2-prong outlets everywhere in their house and they put 3-prong outlets in with no protection in the beginning with a GFI. So it's a little better than that, but it's still not a great solution.
Gotcha.
I recommend people actually live with the 2-wire outlets or add a ground throughout their house.
David designed the defects that we're going to find in different things here and that we found in the main panel and the sub panel. So should we take a look at the rest of the things we see on this wall?
The rest of the defects on the wall? Sure. What I've arranged in these outlets, for example, is various defects that you might come across as an inspector wondering how serious it is and what to do and what to recommend when you see a problem. So our first outlet, number 1, is an outlet that you may come across, and as we've talked about this tool, most inspectors will use this tool. What this will look like is a dead outlet. And basically what that reads, if you were to read the codes on the front of this, it would say to you that this is an open hot. What does that mean? It means there's no hot to this outlet, obviously. However, if I use my tool, there is a hot in this box, but there's no hot on this outlet. So, if we remove this outlet, now this would take a qualified electrician to do, but all you would as an inspector probably report would be that there's a dead outlet. But somebody forgot to connect this black wire right here with the rest of the wires so that this outlet would be hot. So
we just report that it appears to be inoperable.
Exactly. But what I'm trying to do is give you a sense of, well, what does that mean? How did that happen? You shouldn't go around fixing. However, it's nice to have an understanding of what the problem could be. Now, after connecting up that black, this reads, I don't know if the camera can see, but these 2 lights on the right side of this indicates that the outlet is operating properly. So, that's all that needed to happen to fix this outlet, and you got a reading of an open hot.
So if an inspector was looking at a main panel and everything looked connected and the circuit breakers were all turned on, but there was an inoperable outlet, it could be this problem.
That's correct. On this outlet, however, you stick your tester in here. Looks good, doesn't it?
Yeah.
Well, it's very important to take a few outlets out in a house, because sometimes what you'll see when you do that, even though they all read great, it's good to see what kind of electrician did the work. Because this outlet you can't even pull out to look at because the wires are too short inside. That can be a problem. Everyone that switches and changes outlets, the wires keep getting shorter and shorter, and eventually you can't even get these outlets out to mess with them.
Especially when it's been backstabbed like this one instead of the screws used.
Correct. There's nothing illegal about using the backstabs, but in this particular situation it just makes things very difficult. So I would make a note, if I was an inspector, that makeup wires or, outlet connections have very short wires. And that is not the code. That's not okay, and could cause problems down the road for the owner, future owner, or the next owner.
A good place to do this might be on an exterior wall where you might be looking for insulation in the exterior walls too. That way you could look at the outlet and you could also check the insulation.
Sure. You only need to check a few outlets. Generally, whoever did the work on the house was consistently good or consistently bad.
Or one person who didn't know what they were doing replaced that particular outlet, so you should check another one somewhere else.
Yeah, check a few outlets. Mm-hmm. Don't assume that what you see by just using one of these devices will tell you the whole story. Outlet number 3, if you stick your plug tester in there and read what just one light means, it means that you have an open ground. In other words, the ground's not connected. So, might be good, and that's what you would put on your report, is that you have no ground connected to outlet number 3. However, when I come along as an electrician and open this outlet up, well, what do you mean no outlet, no ground? That looks like a ground connected. What that means to me is it's connected here, but somewhere else it's been dropped out. This can be an expensive and long-term fix. I might have to take out a number of outlets on this circuit and follow the wire to find out where that outlet, where that ground has been dropped.
So there's no way to test that electronically to locate within several feet where the break might be?
No, it's basically about pulling out the nearest outlets and finding where that ground has been dropped.
Is there anything that's typical about how those grounds get dropped? Is it usually in another outlet or junction box?
Could not be connected in the circuit panel. It could not be. It could be. Someone could have put a screw through it in the wall if it was too close to the wall. It could be any number of things. That's why your job sort of ends at the tester, you know, because then you have to go into a lot of investigative work. Right. But it's good to know how these things happen, I think, from your standpoint.
We get asked, you know, the client is going to say, well, how would that happen?
Right.
You know,
and those are some great answers. It could be a screw through it, could be out of the panel, could be the next outlet down the way. I don't know. You'll have to call an electrician.
Yeah.
Number 4. Now, this reading on this says there's an open neutral. When I say open, that means unconnected. Okay? So when we pull this in, well, it looks like the same thing that went on with the black wire over here is now going on with the neutral wire. This wire got left out of the mix and did not get connected. And if I connect it,
is that usually just something somebody forgot to do?
well, sometimes it's under a wire nut and it's loose.
Oh.
You should always twist wires together when they're under a wire nut. Do not expect the wire nut to do the twisting. Always use a tool to twist wires together, like that.
So it could be improper installation also.
It would most definitely be improper installation. But again, the neutral could have fallen off back in the circuit panel. You know, your job ends pretty much here, but it's good to know what some. So here we have a good reading again on number 4. So number 5, outlet number 5, you will see it reads great, and it is great. What I'm trying to show you here is another way that grounds can be connected that is totally approved, but very different from what you're likely to see. For example, back in this outlet we just looked at, notice the grounds are all twisted together and connected under a wire nut and then pigtailed to the outlet. This is called a pigtail. That's fine. That's the way I like to do it. But older electricians, and believe it or not, there are older electricians than me, some like to use what's known as Buchanans. This is very legal. This is a Buchanan. And what happens is they twist all the wires together and they use a crimp sleeve on the grounds, which then their pigtail goes out. This is just like a wire nut, but that's fine. If you see this, there's nothing wrong with that.
Can I use my fishing crimp?
No, you must use a proper Buchanan crimping tool. That's why these are called Buchanan's the company, and that's why these are called Buchanans. So this outlet, as I put a tester in, reads, if you look at the chart on the outlet, this reads reverse polarity, which means that the hot wire is your neutral and the ground spade, the neutral spade is your hot. So these wires have been reversed. And sometimes they've been reversed right here. Sometimes, once again, they've been reversed somewhere. You might find 5 of these in a row, because if they're reversed down there, they're going to be reversed over here.
So reversing them at the upstream end of a series of outlets.
Then all the others will be reversed as well. However, in this particular instance, what we have is simply as simple as the white wire has been put on the black, and the black wire has been put on the neutral. So you switch them here. Now that's not always that simple, but you switch them here, put your tester in there, reads great.
Can you wind up with bad connections where people have yanked the backstab wires out and pushed them back in a number of times?
Absolutely. That's why you noticed when I pulled these out of these backstabs here, I used the 2 fresh backstabs that had never been used. If these are at all loose or sloppy, I will use the screws instead of the backstabs. So
it might be a good idea to wiggle your tester while it's plugged in.
That's a great idea. These testers, this is actually a great tester. When you have an outlet in place, and you stick one of these testers into it and wiggle it a little bit, if there's a loose wire or a loose connection, that will show up on your reading. And that's really great because that could tell you a lot of information about where a problem might be. Okay, so let's look at number 7. Let's see what it says. Well, it reads just fine. And this is a GFI outlet. And, looks like it's feeding light number 7. So on this same circuit, feeding downstream, even though it's above, feeding downstream of this GFI is this light switch, and consequently this light. So if this GFI trips, this light will go off. So this is a properly wired line and load GFI.
So if an inspector were testing GFCIs and he tested one, say in an upstairs bathroom, and it didn't have the reset button, it was controlled by another GFCI somewhere else in the house, and he didn't want to stop what he was doing and go look for it, but he thought he'd continue on with his inspection, then he might find a light somewhere that would appear inoperable, but it might be connected to that GFCI. It might be on that circuit. So instead of writing up that light or that switch as inoperable, he might wait, or he might try it again after he's found the controlling GFCI and reset it.
That's correct. In a home, generally all the GFCI outlets in all the bathrooms are connected and downstream of one either GFCI breaker or one GFCI outlet. So when you go around with your little tester, with your GFCI tester, which will trip a GFI outlet, you have to find that outlet somewhere, because now none of the bathroom outlets are going to work. Perhaps none of the lights are going to work in that bathroom, and it's all because the GFCI circuit is out.
They can be pretty well hidden sometimes too.
And they can be very well hidden, and that can be, that can take hours. I literally have searched for hours for an outlet that I've tripped. And so what I like to do is find the GFI outlets first, and then mess around with tripping bathroom outlets to see if they're GFCI protected. So I know where most of the GFI breakers and outlets are before I get started.
Every once in a while I come to a GFCI outlet, and when I test it, it makes a little buzzing sound when it trips. And it seems to me that most of those have been exterior GFCIs, and they've had reset buttons with them. Are you familiar with that problem?
Well, I think what you're experiencing is just something that's a little older, a little less. These are very new smart lock GFI outlets, whereas they've made GFCI outlets since 1970, and some of them are just kind of still hanging in there, and they'll make noise when they trip and whatever, but they still work. I recommend changing an outlet that makes a buzzing noise like that, because it might be just on its way out.
Every once in a while we find some that will trip, but they're really soft, or they just don't feel right. And I usually recommend those get replaced too, because they're on the way out.
Good idea. Any outlet, any GFI outlet you see with a light in it like this, that's not a light like this, but a light in the outlet. That's pretty new. So you know you're in the newer vein. Number 8 down here is reading that the neutral is actually hot. And that's all it's telling me with this tester. Let's open it up and see what we've got.
Mm-hmm.
Well, what this outlet, the hot has been connected to the neutral side of the outlet. This will obviously not work because there is no neutral going to the outlet.
Is it a problem if you pull an outlet out and you see a little chunk of wire sticking out where somebody couldn't get it out of the backstab and just cut it off? And
yes, and that's just what happened right here. I tried to get this all the way out and couldn't. The way you're supposed to take, and sometimes I can and sometimes I can't, the way you are supposed to take these wires out is by pushing in to the loosening device and then pulling the little piece of wire out. But it's not, if you see a wire sticking out of the back of an outlet, that's not a good thing, and that's something you want to either remove or call attention to, because that's a hot wire. So, as I said, this black wire, which I've now shortened, has been stabbed into the wrong side of the outlet. It should have been on the black side, and was on the neutral. It should have been on the hot side, and it was on the neutral side. And in here, lo and behold, we find a neutral that has not been connected. And using the stab that's not been used, we reconnect it. Did I give you my tester? I did. And that reached just fine.
Mm-hmm.
So that's some of the problems you'll run into. As you noticed from our last experience, all these outlets are live. We're dealing with hot wires here, and I'm used to doing that. I don't recommend taking apart electricity hot unless you really know what you're doing.
Mm-hmm.
As we go to number 9 down here, what this is reading, and this is a good example of what we were talking about before. Remember when we were talking about the 2-wire, having a 3-wire outlet on a 2-wire system? What this is telling me is there's no ground. Well, if there's no ground, why is there a 3-prong outlet here? Well, let's see what's going on in here. Often what will happen is that homeowners who don't know any better will go and put a 3-wire outlet for convenience when all they've got is 2 wires coming into the box.
Very common.
So we don't have a ground. This is very common and very dangerous and should be called out, because this should either be replaced with a 2-wire outlet or the entire circuit GFCI protected.
Oh, that's something you don't like very much, is that right?
I don't subscribe to it. I do it because it is code and it's legal, and many people insist on having 3-wire outlets in their house, and that's the only way you can do it when you've got a 2-wire system. So outlet number 10 looks fine, but I happen to know, because I put it together, and this is something that, if you see, is actually a pretty dangerous thing. Someone has used the screw connections, which is great, but they've put the screws in, they've put the wires in counterclockwise. The only way that a wire is tightened properly under a screw is if it's wrapped around the screw clockwise. So both of these wires will loosen up over time, and if you look, the neutrals are the same way. And I don't know if you'll ever run into this or see this, but it's very important that all wires get wrapped clockwise around a screw so that the tightening of the screw tightens the wire. Notice how that wire fell off of there because it was counterclockwise.
So if they're installed tightly counterclockwise, they can still loosen up over time?
You just saw it, absolutely.
I mean,
but if they're installed tightly...
I mean, when they're not being yanked around, they can loosen by themselves?
That's correct. Sure.
Just from the vibration of the wire?
Vibration of the outlet, plugging something in and out of the outlet, in and out of the outlet, you know, they could fall off of there. But notice how much tight, I mean, this thing is tight as can be if it's screwed in clockwise. Number 11. Reads just fine, but on a closer look, these grounds have been made up and twisted together without any kind of either wire nut or Buchanan, as we've shown before. So this is not a proper connection to ground. This could easily lose its grounding connection just over time by loosening up because there's no device on here to keep this connection tight, either a Buchanan or a wire nut. So if you see grounds twisted together, and I see this all the time, without a wire nut or without some kind of device to keep them connected, that is a bad sign. This is a most dangerous situation. Rarely will you ever see this, but if you ever see your lights light up in this fashion, what that means is that the hot and the ground are reversed. If that's true, what that means is that the actual screws and yoke of the outlet are going to be hot. That means that this, and they are.
Does that have to be a metal box, or what if it's a plastic box? Will it still be hot? I mean, it wouldn't conduct.
This is a plastic box, and it is hot. So someone has put the hot wire on the ground. Well, that someone would be me, but I did that as an example, of course. Someone put the hot wire on the ground and the ground wire on the hot. So that, of course, is a potentially very dangerous situation, and all you have to do is touch this with a bare finger and you're going to get a shock.
What about a metal cover plate? Would it be energized also?
Well, in this situation, if this was a metal cover, the whole cover plate would be hot.
And since this ground wire is then energized and it's connected to other ground wires, then other devices are allowed to be energized also.
Absolutely. Absolutely. A most dangerous situation. I don't recommend against metal cover plates because if your grounding is proper, it's no problem. All the screws are grounded and they follow the grounding path back to the ground. But in a situation like this, so notice, the hot wire is on the green grounding screw. Quite a no-no. And the ground wire is attached to the hot. So we're going to pull this wire out just to show you the proper way to pull it out. And now we can put the ground where it belongs. Clockwise, of course, on that screw.
I guess one of the other things that inspectors should be looking for, as long as they've got an outlet removed, is to make sure the wires haven't been nicked too badly when they were stripped.
Absolutely. And that can be, I've seen a lot of that, because some of these tools used for stripping can damage the wire.
Mm-hmm.
So now we've reversed that hot and ground, and we're back where we should be. Outlet number 13 shows this light on, which makes you think the outlet's fine. This is a GFI protected outlet, but you'll notice it will not trip, nor will it trip even if you use the tripping device on the outlet.
And nothing was lit. No lights were lit on the tester.
And no lights were lit on the tester, which means this reads as a dead outlet. But this light would not be on if there were power there. So what's wrong with this picture? Well, this is the line, and it is connected to the load. And the load, which is over here, is connected to the line.
So the hot and neutrals are reversed.
No, the line and the load on the GFI outlet is reversed. The lines are proper and the loads are proper. I mean, the whites and the blacks are in their proper place, but they are not properly done to line and load.
So can you explain, when we were looking at other outlets, there was no mention of line or load. So what does that mean with this outlet?
Line is the power coming in, and load is the power feeding off of that line. So the line is the power coming in from the circuit panel.
Right, the supply.
The supply. So if you test with this, you will see that's your load, but that's your line. This was connected to the load, this was connected to the line. The outlet will not work. So if you connect the line to the line, and that means the line neutral and the line hot.
What means the line neutral and the line hot?
Neutral, hot. Line neutral, line hot. Load neutral, load hot. Line is now connected. This outlet will work and trip, but it's not feeding anything.
Right.
Until we put the load in. And once you put the load in, properly, guess what? Circuit 13 works, which includes this light switch above my head. Let's turn this other one off. And if I trip that circuit, the light goes out.
And if we test it with the tester?
And if we test it with a tester, we will see.
There we go.
And there goes the light. So, Ken, here's a good example of why I don't like feeding 3-wire outlets that only have 2 wires connected to them, as we talked about in an old home. What we have here is in this outlet there's only a 2-wire feed. There's a 2-wire feed to here and a 2-wire feed from there up to this light.
So there's no ground?
There's no ground from here on, all the way up. I'm going to turn this light off. All the way up to that light. If you trip the GFI, everything goes off, including the light. However, if you try to trip your GFI with this tester, because it's a 2-ground GFI, notice it reads as having no ground, it will not trip that GFI. I'm pushing that button, but it won't trip it. It won't trip it down the line. But by code, this is a safe installation.
Just out of curiosity, if this were a metal box and the outlet were wired to the metal box, would that show up as a ground and would you be able to trip it?
No.
Okay.
You would not.
What's going on with this one?
Well, these 3 outlets are all examples of aluminum repairs. What I mean by that is, as an inspector, you'll often come across aluminum wiring in one of these old houses that was built in, say, 1970 or so. Well, there is a proper way and an improper way to fix aluminum wiring. This is an improper way. So here is your aluminum to copper splice. Dangerous because it's dissimilar metals, and aluminum heats and cools and can cause melting and arcing. Using deox compound inside this wire nut may help to protect some, but it's not approved by code.
So the aluminum vibrates and contracts and expands at a different rate from copper, and that's one reason the connection degrades?
That's correct. And heats and cools quite a bit as well. So here you have the aluminum directly to an approved COP aluminum device, and you're going to have come close with that camera to be able to read this, but there is an indication on the back of this outlet and on the front of this outlet that it is approved for copper and aluminum wire directly to the device.
So you could see that Copalum, if you took the cover plate off, you wouldn't have to take the outlet completely out. Is that right?
You should be able to see it by just taking the cover plate off. But basically on the back of the outlet, it says it even more clearly. And then let me flip it over. These are expensive, but this is one approved way of splicing aluminum to copper. There's another one.
I'm sorry.
Go ahead, no problem.
But that's not a splice, actually.
I'm sorry. Of connecting aluminum wire to a device. This is one approved way. This is not approved, and this is an approved splice technique. These are called purple wire nuts, and they have been made specifically for the purpose of connecting copper and aluminum wire, and they have a special deox compound built inside of them, and they've been UL approved to connect a copper wire to an aluminum wire.
I've seen some of those burned.
Have you really?
Yeah.
I have not. I've installed millions of those.
Oh, I know they're approved, and they're
Yeah.
one of the few, other than Copalum crimps, I guess, they're one of the few approved methods.
And the other method is the crimping method, which I don't do, but it's quite an expensive fix. But these are the 2 approved methods that I use, and this is not okay.
What do we have here with these last 3, 19, 20, and 21?
Well, 19, 20, and 21, if you'll notice, are all metal boxes. And what I'm showing you is proper grounding with a metal box. Grounding is so important in the electrical world because it's a safety issue. And what I've shown you in these is 3 ways. Only one of them is the proper way to completely ground a device in a metal box. And that would be number 19. Number 20 your ground is grounded to the metal box, but without this device connected to that metal box, there's no ground to this device. So not only must you ground the metal box, but you also must ground the device. So here in number 19, you'll see there's a pigtail back here that grounds the box under this wire nut, and the grounds in and out, and has a pigtail to the device. So even with the device out here, it's still grounded. With the device, and the box is still grounded. If you look at 21, you'll see, yes, this device is now grounded out here. So it's always grounded. Oh, but wait a minute. The box isn't grounded with the device out. So they were using the device to ground the box, and without the device plugged in, the box isn't grounded. Here, they were using the box to ground the device. So when the device is pulled out, the device is not grounded.
Right.
Here, you're covered no matter what. Device in, out, box is grounded, device is grounded.
Is there some reason for this electrical tape?
No, I always like, especially in a metal box, yes, there's a reason, but there's no code that says you have to do this. It's just what I do. I always protect my devices in a metal box from these screws hitting the sides of the metal box. It's really tight in there, and it's just an added little safety that I like to do. So that's your wall of shame that I've created, covering just about every kind of instance of malpractice that you'll come across in the electrical business. Is there anything else you want to ask me about this wall?
Just maybe we should cover right quick. We have 2 different recessed lights here. Can you talk a little bit about those?
What I wanted to show with these lights is one of these lights is rated to be up against, have insulation packed right up to the fixture around it, and the other one is not.
So one's IC rated and
One
one's
is
non.
IC rated, which means suitable for insulation, packed up right around it, and one is non-IC rated, which means it needs a 3-inch barrier around it. And it's difficult for an inspector to tell unless he takes out the bulb and the trim, because inside of every can it will tell you whether it's IC rated or non-IC rated.
So it's not necessary for an inspector to actually crawl back into the corner of the attic and
Not
pull
necessary at all, because inside the guts of this can will be stated non-IC rated, no insulation within 3 inches of this fixture. That's what it says in here. And this one on the inside says IC rated, insulation may be packed right up to the fixture.
I've been in homes where there were a number of recessed light fixtures like this, and they were shutting off intermittently.
That means there is a heat sensor which is built into every fixture, and often the reason that that's blinking is there's too big a bulb. They're only rated for a certain size of light bulb, and if you put too big a light bulb in there, they're going to blink. It's going to heat up, shut off, cool down, turn on, heat up, shut off, cool down, turn on.
Might that also be an indication that a non-IC rated light fixture had insulation packed up against it?
It could be, absolutely, but I wouldn't count on that as protection. That's it could also start a fire.
So, if you see a light shutting off intermittently, you should look at the bulb, and if the bulb seems like it's the right size, then maybe look in the attic when you're up there to see whether it's covered.
Absolutely.
Well, David, I think that's it. Thanks for being with us. It's David Ruskay from Positive Energy Electricians, working in Boulder, Colorado. Really appreciate you being here, David.
Thank you, Kenton. Glad to do it.